All right, 103 out of 96. Determine the appropriate number of standard error bars necessary to give the prescribed level of confidence. Do not read between the entries. Normal table. Use the closest value, okay? The appropriate number of standard error bars. Standard error bars. So if we're doing 80%, then we would have to go standard error bars of what, 40% on either side. And so we'd have to use the coefficient for 40%, an area of 40%, which is somewhere between there and there. It's closer to this one, so we'd use 1.28. So we'd use 1.28 standard error bars, and that's what this S divided by the square root of n is, a standard error bar. Okay? So that's what we would use. And if we had to do, let's see, there was also question 106. What if it was 68.26? Which means we would cut that in half, and it would be 34.13%, which is the one z-score over one error bar. So we'd use 1 for number of error bars. These are the error bars, one of them. That's 106. And then the next question was 118. So 118 says the wind velocity measurements on Mount Rainier, and I did this one in class. Set a 95% confidence interval for the true norm. So what I did in class was, I think I typed it in because it's the easiest way to do this one. Stat, edit. So let's just go over here and we go, I'll put them in list 2 here. 21, 25, 34, 18, 17, 3, 21, 24, 32, 20, 17, 25, 27, 26, 30, 9, 24, 19, 16, 17, 26, 23, 17, 29, 25, 12, 10, 23. Now if I've typed them in right, I should be able to do stat, calculate the one variable statistics on list 2, and it tells me that the sample mean was 21.07, which we think is approximately the population mean. The sample mean was this. We think the population mean is similar, but we can get a confidence interval, and they said for a 95% confidence interval, which means you go 2 standard deviations out. Well, we don't know what the 2 standard deviations, so we use the margin of error, which is the population standard deviation, 2 of those, divided by the square root of the size of our sample. And we had 28, it says here in the calculator. So we divide by the square root of 28. But we don't know the population standard deviation. So we do another estimate, which we use the sample standard deviation, which it says here is 7.1. And since we're using this, which is approximate, we're getting more and more approximate here. So we'll just round this to 1 decimal place, and we'll take and do this whole thing to 1 decimal place. So I'm going to do 2 times 7.1, which is 14.2, divided by the square root of 28, and I get about 2.7. So we think then, we're 95% sure that the wind on Rainier, on average, for all the populations, all the times, will be 21.07 plus or minus 2.7. So we'd round this to 21.1 and go 21.1 minus 2.7, and we'd say it's somewhere between 18.4, the true mean of there, 95% sure. It's between 18.4 and we equals doesn't really mean anything. You could just do between, and 21.1 plus 2.7, which is 23.8. Okay, 95% sure that's what the wind on average would be for the actual all the wind measurements. Okay, next one was 119. Set a 90% confidence interval. So we would do exactly the same, except for 90 we would use, it says in the book here, 1.645, and also on the sheet I gave you. So for this was a 95% confidence interval. So we do everything the same, except now instead of 2 we'd use 1.645. So we're going to have 1.645 times 7.1, I'm rounding here quite a bit, divided by the square root of 28, and I go plus or minus 2.2 to the 21.1. I go plus or minus 2.2, and I think you could do the math to figure out the interval then. Add 2.2 and subtract 2.2 from 21.1, and that would be 119. And then the next one, 121. Okay, so I'll do this on another page in another video.